Final exam practice paper, page 4. So here when we look, we want to differentiate y is equal to 2x squared minus 5 divided by 3x plus 2. So this will be our u at the top and our v at the bottom. So u is equal to 2x squared minus 5. Differentiating u with respect to x will give us 4x. V is equal to 3x plus 2. Differentiating v with respect to x, we're going to get 3. Now putting our quotient rule together. dy on dx will here be our v, so v first, 3x plus 2 times our du on dx, which is 4x, minus our u, 2x squared minus 5, multiplied by our dv on dx, which is 3. All divided by v squared, 3x plus 2, all squared. So we multiply this one through. 3x times 4x gives us 12x squared, plus 2 times 4 is 8x. And we're going to keep this one in brackets until we work through, just because we have this negative sign in front. 2x squared times 3 is 6x squared, minus 5 times 3 is 15. Here on 3x plus 2 all squared. So 12x squared plus 8x, then we've got minus 6x squared, and then we've got negative 15, so plus 15. All on 3x plus 2 all squared. So with our x squareds, 12 minus 6 gives us 6x squared plus 8x plus 15 divided by 3x plus 2 all squared. Okay, now looking at number 20. So we're going to look here, we've got cosine of x multiplied by e to the power of 5x. So here this will be our u and this will be our v. We have u times v. So u is equal to cosine of x. We differentiate u with respect to x, and here we're going to become negative sine of x. So v is equal to e to the 5x. Differentiating v with respect to x, it's a v. Here we bring down our 5, it'll be 5 e to the power of 5x there. Now putting this into our formula, dy on dx is u times dv on dx plus v times du on dx. So here cosine of x multiplied by dv on dx is 5e to the 5x plus v here is e to the 5x multiplied by here negative sine of x. So the first thing we can do is we can look at this and we can say, okay, well we have this term e to the 5x in both. So what we'll do, we'll bring that out the front just to make our life easier. E to the 5x here, and then we're getting cosine times 5. So 5 cosine of x plus, here we've taken this out and we've got negative, so this becomes here minus, so minus sine of x there. So now looking at number 21. We want to find here, we want the equation of a tangent. So remembering our tangent and our normal, so here our gradient will be our dy on our dx. We have our formula here and they've given us the point here, x is equal to 0. So first of all, we've got y is equal to e to the power of 5x here. If we substitute in, x is equal to 0. Therefore, so at x is equal to 0, y is equal to e to the 5 times 0 becomes e to the power of 0. Anything to the power of 0 is equal to 1. So when x is 0, y is 1. Now we want to find our gradient, is our dy on dx. So dy on dx, here we bring our 5 down, becomes 5 e to the 5x. So here at x is equal to 0, dy on dx will therefore be 5 times e to the 5 times 0 is 5 times e to the power of 0 will be equal to 5. So we know at this point our gradient is 5. So now at our point 0, 1, so this is our point here that we found when x is equal to 0, and we're interested in our equation of the tangent. So equation of the tangent, our y, our change in y minus 1, this is our 1 here, is equal to our gradient, 5, multiplied by x minus 0. So if we look here, our 0 has come from here, our 1 has come from here, and our 5 has come from here. So now we've got y minus 1 is equal to 5x. Y is equal to 5x minus 1. And this is for our equation of the tangent. Next we're going to look at the equation of the normal. Remembering our gradient for our normal is 1 on our gradient for our tangent, because it's at this same point x is 0. So we're still using our point 0, 1, and here our gradient will be equal to 1 on 5. So the other parts of this are still valid. We're going to say y minus 1, it's the same point, is equal to 1 on 5, x minus 0. So here we'll go red. Our 0 is from our x here, our 1 is from our y, and our 1 on 5 is our gradient here. So from this we're saying, well, y minus 1 is equal to 1 on 5x, or y is equal to 1 on 5x plus 1. Sorry, that should be a plus 1 here for our, and this is our equation of the normal here. Okay, so moving on to question 22. We want to differentiate here y is equal to our natural logarithm of 4x squared minus 3x. So we're going to set this as our u. U is equal to 4x squared minus 3x. So we can differentiate with respect to u. Du on dx, 4 times 2 is 8x minus 3. And then we know, well, dy on dx is 1 on u multiplied by du on dx here. So 1 on u becomes 1 on 4x squared minus 3x multiplied by here 8x minus 3. We put that together here, we're getting 8x minus 3 on 4x squared minus 3x. Moving on to question 23. We've got here y is equal to the cosec of sec of x here. So we're going to say this one here will become our u. Here's sec of x. So u is equal to sec x. We look it up on our tables, we get du on dx will therefore be sec of x tan of x. So putting this into our original formula, we're going to dy on dx here will be negative cosec of the sec of x multiplied by cot of the sec of x multiplied by here our du on dx is sec of x tan of x there. Okay, so moving now to 24. We've got a few bits of information in this. Our curve contains the point negative 2, 11, and the gradient of curve at any point is 3x squared plus 3x plus 1, and we want to find the equation. So we know our gradient is our dy on dx is 3x squared plus 3x plus 1. We're wanting to find our equation. So here we're going to say, well, y is equal to our integral of 3x squared plus 3x plus 1 dx. Here this becomes here 3x, we've got 3 and divide by 3 plus 3x squared divide by 2 plus x plus our constant c. these 3's will cancel out, and so we're going to end up with x cubed, y is equal to x cubed, plus 3x squared on 2 plus x plus our constant c. And we've been given these points here, -2 and 11 lie on this point. So we set our y is equal to 11 and our x is -2 cubed plus 3 times -2 squared on 2 plus -2 plus our constant c. So 11, so here 4, -8, here -2 squared is 4 times 3 is 12 on 2 gives us 6 minus 2 plus our constant c. So if we put this all through, we'll get our constant is equal to 15. So our equation, we'll be able to put this in for our constant here. Our equation will be y is equal to x cubed plus 3 on 2x squared plus x plus 15. Okay, now looking at number 25. So we've got here, we want to integrate between 0 and 1, 2x minus 3 squared here. So here our first step is, here we're going to say, well, we've got 2x minus 3 to the power of 3 divided by 3. And then we remember we also, when we go through, we're going to put our differential of our u in here too. So here 2x minus 3 gives us divide by 2 here, and 1 between 1 and 0. So here we have 2x minus 3 cubed on 6 between 1 and 0. So we can substitute this in. Here we've got 2 times 1 minus 3 cubed on 6 minus 2 times 0 minus 3 cubed on 6 here. So what we have, 2 times 1 is 2, minus 3 gives us minus 1 cubed on 6, minus 2 times 0 is 0, minus 3, so we have -3 cubed on 6 here. So now we have -1 cubed gives us -1 on 6, minus here -3 cubed gives us -27 on 6 here. So here -1, minus 27, so we're going to plus 27, so this gives us 26 on 6, which is equal to 4 and 2 on 6, or 4 and a third. And then last for this page here, we have question 26. We want to differentiate here, and we've got an inverse sine function here. We're going to say, well, here this is our u. U is equal to 4x squared, du on dx is equal to 8x. So here we say, well, our formula is d on dx of our inverse sine of u is here square one on of minus u squared, here du on dx. So here we're going to have 1 on the square root of 1 minus 4x squared squared multiplied by 8x gives us 8x on the square root of 1 minus 4 squared is 16, x to the power of 4 here.